Welcome to the Copernicus Project video series, Teaching Science in 5 Easy Pieces. This module focuses on biology. We've formatted the videos so that you can watch them in sequence like a feature film or instantly drill down to a specific video or chapter that addresses your own area of interest. Because some viewers may be jumping around to various chapters and videos, our introductions contain some of the same orientation information. The easy pieces are the 5 E's that comprise a learning model known as constructivism. Traditional education is teacher-centered, while constructivism is student-centered. It's based on the concept that students learn best when they're actively engaged with their subject matter rather than listening passively to a lecture. Studies show that students learn science best by doing science, not hearing about it. The role of the teacher is then raised from someone who is simply dispensing information to someone who structures activities that improve communication, that challenge students' perceived notions, and that help students build on prior knowledge. In this and in each of the other videos, we show classroom examples of how you can use the 5 E's to get students actively involved in their own learning. Each video is broken into 5 chapters, one for each of the 5 E's: engage, explore, explain, elaborate, and evaluate. You may use the menu function to instantly jump to any classroom chapter focusing one of the 5 E's. Each chapter will be preceded by a brief explanation of how that particular E should progress, as well as the roles of the students and the instructor. The first E is engage. It's all about involving the students in something they are interested in. Ideally, it will be tied to science content to be covered later on in the lesson. During the engage, students first encounter and identify the instructional mission. Here they make connections between past and present learning experiences.
On the white screen, we see what? Talk amongst your group, or actually think, what's different about those birds? Think first.
Yeah,
It looks like kid has a witch nose.
yeah.
And one has a really sharp, pointy one.
Yeah, it's like because the stork is just like straight.
It rips it apart.
The stork is just like straight. It doesn't like bend or anything. Yeah, it's like the eagles is like really curved.
They lay organizational groundwork for activities ahead, and they stimulate their own involvement with their anticipation of these activities.
Let's say focused on beaks, even though we see a bunch of other different things. So Harley, what's one thing that your group noticed about the beaks?
That they're really pointy and sharp, and that one's like curved.
Which one's curved?
The eagle. And
Why do you think the eagle has a curved beak?
so it can pick things off the ground.
Excellent. Pick things off the ground.
You can engage a student by asking a question, defining a problem, surprising them with an unexpected event, or acting out a problematic situation. This gets a student focused on the instructional mission. It's not unlike the marketing of a product. First, we need to grab the customer's attention. We do that by stimulating a sense of need. Once the student feels that basic need to know, he's motivated to take the steps necessary to satisfy his own natural human curiosity.
I'm really trying to get him to focus on the different beaks of the birds. Specifically, Darwin studied the finches of the Galapagos Islands and how over time the birds develop different beaks for different activities. So I was trying to get my students to kind of relate to different tools, have different jobs. So, and again, but I still wanted to focus on the beaks, so that's why I have this tie, where I have my little eagle with his predator beak, and then I titled the lab the Spoonbill Lab, so I have a picture of a spoonbill, and I have a picture of a pelican, and I think I have a picture of an owl, and probably a crane, because cranes are really good at spear fishing. And there's a really good United streaming video that does similar things. So I just wanted them to look at the birds and look at the different beaks and start realizing, you know, those are distinctively different. Why? Victoria, what did you notice about the beaks?
That they have different beaks because they live in different environments and need to have different beaks to catch different kind of food.
Okay, so Tori, you've been quiet. What do you notice about these 3 birds?
That the hummingbird has a very long beak and the eagle has more of a pointed and rounded, sharper beak.
Okay, and from this picture, would we think that The stork is larger than the eagle? Yes. Based on this picture, but in real life we know
The eagle's bigger.
eagles are huge. Okay.
The second E is explore. In this step, students experience scientific phenomena and materials firsthand. They examine it and they interact with it.
So now today we have the idea, we're looking at beaks, so you're going to go out and be birds, and you're going to get a chance to use 2 different types of beaks. Sorry, you don't get to fly. Why can't people fly?
Yeah.
Why do you think?
Wings. Because we have big brains and
Big brains.
because our bones are not hollow.
Bones are not hollow,
Because they're smart enough to make stuff.
because we're smart enough to make airplanes.
We don't have feathers.
We don't have feathers.
We don't have wings.
We don't have wings.
We have
It's
arms.
gravity.
Yeah.
Gravity's fault.
It keeps us
Yeah,
down.
gravity doesn't.
So some of us are kept more down than others.
Yes, some of us stand tall.
More gravity.
As they involve themselves, students develop a personal relationship to the mission. Working together in teams, students build the base of common experience, which will help them in the process of sharing and communicating.
This is excellent. You guys are thinking about how their beaks are used, what the animals do with their beaks. And so now we're going to go outside, and you've got beaks. You've got beaks in your little cups, and we're going to use those.
The teacher acts as a facilitator, providing materials and guiding the students' focus. It is the student's own inquiry process that drives the instruction during an exploration.
Okay, so remember, one of you has a clothespin, one of you has a spoon. You're going to spend 1 minute collecting seeds and count what you get. And so everyone has a bill. So all the spoon bills stand up. What I found incredibly interesting with the lab during the Explore part is I had the students work in groups of 2, but instead of having like one person watch and one person involved, one partner had a spoon and one partner had a clothespin. And they were trying to collect seeds. And I didn't make it a competition. It was just, we were collecting different seeds in the grass. And I had pinto beans and lima beans, so I've got brown seeds, white seeds in there. And the kids were picking up seeds. And I found that 2 minutes was about the max of time that they could handle. And so they picked up their seeds and they poured them out and they counted them and everything was kind of fine. But then when I had them switch equipment, that's when it got exciting. Okay, go back to your little seat and count what you have.
17.
Good, so your hypothesis was excellent. Because now all of a sudden they're using somebody else's beak instead of a spoonbill or the clothespin beak. And all of a sudden now you could hear these things, oh, it's much harder, how'd you do that? And they were trying to interact and figure it out. And so that was quite exciting to just then see the interaction going around. And the kids were great with the activity. I mean, they were outside, but just the interaction when they had the new implement was what was really neat. Because now all of a sudden there was something different, because when they started out, that was their normal. Now I took them out of their normal. So what do you notice now that you're using a different implement? Is it easier or harder?
Harder.
Easier.
Harder. Hard.
Easier.
Difficult.
More confusing. Not your fingers there, Patrick.
I'm not.
Okay. You're supposed to be picking up seeds.
The third E is explain. This is when your students, all of them, explain what they found during the explore stage. Language motivates a student to sequence events he experienced into a logical format. Communication occurs several ways: between peers, between the teacher and students, and within the learner himself. Working in groups, learners support each other's understanding as they talk about their observations, ideas, questions, and hypotheses.
You've been outside. You guys explain in an excellent way all the different things that you discovered in using the clothespin and using the spoon. And most of you found that for the type of seeds we use, the spoonbill worked better. Well, now, going along with the same idea and going with our standard about Darwin, so we need to try to figure out what was Darwin thinking.
I think the spoon worked best because it had a scoop and the clip just couldn't pick up anything.
Yeah, because the clip is like harder to use, and then like how she said, the white did stand out more because the brown like blended in like with the dirt and stuff.
Yeah.
It's easier to use the spoon than it is to use the clip, just maybe as birds, they use better beaks when they're scooping up.
This process leads to a communicable label, which gives a learner the means for sharing explorations. A common language enhances the sharing and communication. The teacher can augment that common language by providing labels for student findings and events that correspond to historical and standard language. The students' created works, such as writing, drawings, video, or recordings, provide tangible evidence of their progress and growth.
In the third part of the lab where we're doing the explain, I first had the students come back in and I had a series of questions, kind of like, expected student responses. But I had a series of questions that I wanted them to actually write down to then focus their thinking into what the activity was all about. And then as at a group, I had them talk about, how many seeds did you get, see the total, compare, talk about the techniques they used to work. And then I started talking to each group and called out, and I charted their responses. What do we know about the different beaks from just our lab?
How they eat and
In our lab, which worked better for you for collecting seeds? Would you be a spoonbill or a pinbill?
the spoon
Why?
because it picks up more stuff.
Okay, so you don't want to starve. Do you think any of these birds could survive in our desert?
Maybe some that have the beaks that have evolved to what is here in the desert, what food and what environment and stuff, and birds who have beaks and traits that have evolved to places maybe with colder weather can't survive here because they don't have the rightful traits that give them anything that can help them get things that they eat to survive.
Okay, excellent.
The fourth E is elaborate. This is the application portion. Can the students take what they've learned and apply it to a new and different area or setting? Here, the students are encouraged to expand on new concepts and make connections. They apply their new understanding to the world around them. These connections often lead to further inquiry and new comprehension. This can lead to that special aha moment in a student.
Excellent job in your explain. Now we're going to take it a step further and we're going to look at the 4 birds that got all this evolution thing started, where Darwin was looking at the finches from the Galapagos Islands. So as you look at the 4 birds up here, what do you notice about those 4 birds, Jose? What I did with my students for the elaborate is I went back, as I said in the beginning, I really wanted them to focus on the finches, but I hadn't shown them to them yet. So I ended up showing them the 4 distinct finches that Darwin studied, and Darwin just was a trip. I didn't realize how young he was when he went to the Galapagos, but they look at the original drawings that he did of the 4 basic finches, and now I ask him to explain what those beaks are for. So since they've already experienced some hands-on beaks, they've already thought about what some beaks could be used for, now we're specifically into natural selection of what were those animals using their beaks for. So what we're going to do now is I want you to take things from your lab that we did outside and write a 5-sentence paragraph. You could write 2 if you want, but you only have to write 1, that deals with Darwin, what he was thinking. How did he come up with these birds having different beaks? Harley.
The 5th E is evaluate. This starts with the student's self-evaluation. They reflect on their own learning experience. It's also an ongoing diagnostic process that allows a teacher to determine if the learner has gained a good understanding of concepts and knowledge. Evaluation and assessment can occur at all points during the instructional process. Concrete evidence of learning becomes apparent as students, teachers, parents, and administrators communicate. This evidence of progress guides the teacher in further lesson planning. The evaluation process is continuous and gives the 5E model a cyclical structure. It's open-ended and open to change. You'll probably find an ongoing loop where questions lead not only to answers, but also to more questions. This can become a jumping-off point for even greater enrichment of the student's education. Instruction is driven by both a predetermined lesson design and by the inquiry process itself.
What I had my students do in the evaluation is I had them write a paragraph to explain what they, actually it ended up being 2 paragraphs, to explain what they had experienced in the natural selection lab that we had done that day, to really, and I had some key questions that I wanted them to answer, but I phrased my question is, support your answer with facts from your lab, so that they had to support the use of a tool or the use of a beak with how it worked in lab to explain natural selection, what would happen. And I asked them some questions also of, like for example, since these were seeds that I hidden in the grass, I'd kind of said, well, if you were a seed and you did not want to be eaten, because I always have trouble with the did nots, what would you do to be different? So they had to kind of talk about how a seed might change to not be eaten. And then I asked them if there were types of food that the spoon would be better suited for, if there were types of food that the clothespin would be better suited for, so they could explain that. And then my kicker that I do probably 80 to 90% of the week, I have a reflection portion that I have them do, which is I call a 3-2-1 reflection. And I've got this from many workshops I've gone to where the presenters always ask you for gots and needs. Well, I'm sure my kids aren't really into gots and needs sometimes, so I ask them, what's 3 things that you learned in lab today? What are 2 things that you still have questions about? And what's 1 thing from lab today that you could explain to someone else in detail? And remember our reflection are 3 things, 3 science concepts that we worked on in class today. It can be facts, ideas that you saw, heard, talked about, read about, things we did in science today. 2 things you have questions about, you want to know more about, or something you just flashed on that really interested you today. And last, in 1 complete sentence, answer today's objective, which you remember is summarize how a new species evolves. Ready, set, right? That last one has to be in a complete sentence. The other ones can be free-formed. So it really gets the kids thinking about what we did in class today. And I find also by looking at what are 2 things you still have questions about, it lets me know something that maybe I didn't cover it well enough, or that kid really wants to learn more about that. So a lot of times I put that on my board as something to table for later, that when we have extra time for something or it suits better, we go into that. So again, I like to do a reflection with my evaluate to give them a chance to again express themselves. And I still have the teacher-directed questions that they answer also. Today, if you all had to use the clothespin and the clothespin only, do you think you would have survived?
I would have died.
Yeah.
No, I wouldn't.
I'm starving.
I would have died.
Okay,
I
so,
would have ate the ground down.
so Victoria, you earlier today talked about the different, when we looked at the flamingo and the blue jay, and what did you think they needed? What I like about the Copernicus 5e format, it's enabled my students to share their answers more readily. I think they become more comfortable with expressing themselves and realizing that what they think is truly important, and even though they're not sure of themselves, they could have the right answer, they could have the wrong answer, and who knows, something that they think is bizarre, maybe research will later show, they were right.
This is just one of 5 videos demonstrating the 5E method as an effective teaching tool. The full series covers physics, biology, chemistry, earth science, and elementary level science. The Copernicus Project and the University of California, Riverside Graduate School of Education created this series with a vision for shaping ideas, shaping minds, and shaping the future. For more information on the Copernicus Project, please visit our website at copernicusproject.ucr.edu or call the number on your screen.
Copernicus Project is a cooperative venture of UC Riverside, the Graduate School of Education, and Dean Stephen T. Bossert, the U.S. Department of Education, and the Office of Post-Secondary Education. we're grateful for the support of many other educators, institutions, and faculty members like you.